Hello everyone. Today I am going to teach you Benedict's test. Before that, I want to tell you why this Benedict test is done. Generally, our blood will contain glucose, and our kidneys will not filter this glucose until the value rises above 160 to 180 milligram per dl. The glucose is present inside the blood and it is not filtered by the kidneys until the glucose level inside the blood increases above 160 to 180 milligram per dl. When the glucose level rises above 160 or 180 milligram per dl, then this glucose is excreted in the urine. When this glucose is excreted in the urine, then we will perform this Benedict test to identify whether the urine is containing glucose or not. If the Benedict test shows a positive result, that indicates the patient glucose value is higher than 160, or also you can say it is higher than 180 milligram per dl. Generally, a kidney is having ability to hold only up to a glucose less than 160 or 180 milligram per dl. If the glucose value increases, then it is excreted in the urine. Okay, so now I am telling you what are the reagents or the apparatus present inside this Benedict test. Okay, the Benedict test will contain a major reagent that is called as Benedict's reagent, which is very much important. The Benedict reagent. The Benedict's reagent will contain copper sulfate. One. Another one is sodium citrate. And the last one is sodium carbonate. These are the three types of chemicals present inside the Benedict's reagent. This sodium carbonate will provide alkaline pH, so that reaction will take place. Okay, and this sodium citrate will not allow this copper sulfate to convert into actually this copper sulfate is present in the form of Cu++. So this sodium citrate will always preserve this Cu++ in this state. Otherwise, the Cu++ will be converted into Cu+. That means it will get reduced when the temperature is increased. The sodium citrate will preserve this Cu copper sulfate in this state. Okay. So what happens is these are the three different types of the chemicals present inside this Benedict's reagent: copper sulfate, sodium citrate, and sodium carbonate. Sodium carbonate will help us in providing the alkaline pH, and sodium citrate will preserve this cuprous ions. Okay. So in the procedure, what happens is when we heat the Benedict's reagent, the copper sulfate the copper sulfate will get dissociated and it will form Cu++ ions. And these Cu++ ions, based on the concentration of glucose, present inside the urine sample, this Cu++ ions will be converted to Cu+. That means they are reduced. Cu++ ions will get reduced. As a result, color formation will take place. Color formation. So when these Cu++ ions will be reduced to Cu+ with the help of the glucose. So if urine contains more amount of glucose, then more amount of Cu+ will be formed and more amount of color will be formed. And these Cu+ ions will form like a precipitate. Based on the concentration, we can observe different types of the colors. To make it clearly understand, I have provided you a diagram here. So now let's move into the diagram. See, so these are the apparatus. To perform this Benedict test, we need Benedict's reagent and a test tube, a dropper and a test tube holder and a spirit lamp. So here I have given the numbers also. This is the first step we have to do, and this is the second step, and this is third, and this is fourth. Okay, in the first step we have to take a clean and fresh dry glass tube or test tube, and you take a 3 ml of Benedict's reagent and heat it on the spirit lamp and observe whether there is any color change inside the reagent. If there is any color change inside the reagent, it indicates that the Benedict reagent is contaminated. Discard it and take a fresh reagent and continue the procedure. When you didn't observe any color change when you are heating the Benedict reagent, then go for the third step and add the urine sample 8 drops in the Benedict reagent. Then again mix it and heat it on the spirit lamp and observe for the colors. If the color doesn't change, if the color remains in the blue, that means the sample which is provided for you is not having any amount of glucose, then you can report it as negative. If the color changes to light green, that means your sample is containing very trace amounts of glucose. If your sample turned into the green color, or yellow color or orange or brick red, then you have to report like this. If it is green, +1. If it is yellow, +2. If it is orange, +3. If it is brick red, +4. Thank you.